Well, now we're going to switch gears a little bit and we're going to talk about the derivatives of exponential functions with bases other than e. Recall from our previous discussions that if you were to take the derivative with respect to x of the function e to the x, our result is the derivative being e to the x itself. And if we had some argument in that exponent position, in other words, we take the derivative with respect to x of e to the power u, where u is a differentiable function of x, the derivative will be e to the u, but times the derivative of u itself. So let's develop our rule here. I have the function y equals a to the x. Now, I'm going to show you a trick right here. Because we know how to take derivatives of natural logs, and we know how to take the derivative of exponentials with base e, we can rewrite this a little bit. Let's rewrite y equals a to the x this way. If I took the natural logarithm of y, it would be equal to the natural logarithm of a raised to the power x. Well, rewriting that using our power rule for our power property for logarithms, the natural log of y is equal to x times the natural logarithm of the quantity a. So how does that help us? Well, in this case, if we take our derivative using implicit differentiation, right, take the derivative with respect to x of the natural log of y, and set that equal to the derivative with respect to x of x times, it's now a constant natural log of a, what happens? Well, when we work that one through, on the left-hand side, we get y prime divided by y is equal to the derivative with respect to x of x times the constant natural log of a, which is to say 1 times the natural log of a. So how does that help me? Well, in this case, y prime dy dx is equal to y times the natural log of a, and you recall that we said at the first, y is equal to a to the x. So y prime is equal to a to the x times the natural logarithm of a. Very interesting. So what are we actually saying about the rule right here? Well, in this case, then our rule goes like this. The derivative with respect to x of the quantity a to the x will equal a to the x, just like in the exponential function, times the natural logarithm of the base a. And likewise, our rule, if we said it was a to the u, would go like this if we take the derivative with respect to x of the quantity a to the u, where u is a differentiable function of x. Then the derivative is going to be a to the u times the natural logarithm of base a times the derivative of u. All right, so let's check this out with a really basic example. What does that mean? Let's say I had the function y equals 4 to the x. By this rule, we're going to use this rule right here. By this rule, the derivative of y with respect to x is going to be equal to the derivative with respect to x of 4 to the x. Working that out, we're going to get 4 to the x, but the base is 4, so we're going to take the derivative 4 to the x and multiply it by the natural logarithm of 4. And so dy dx is equal to 4 to the x times natural log of 4. That's it.